students, how are you doing today? I see that you're prepared for the lecture, and I'm glad to know that. I like the fact that I see your books open, and even you have computers and ready to take notes. I know the other day, we talked about the concept of looking at descriptive research methods. And under the umbrella of descriptive research methods, we talked about a survey method. What else did we talk about, Fletcher? Absolutely, we talked about an observational study. Absolutely. John, what did we talk about too? We talked about the concept of doing a survey study, and we talked about the methods and the procedures for conducting a survey study. All of that comes under the umbrella of descriptive research methods we do. And not only correlational studies, not only observational studies, which you are in the process of doing, and now we're going to be conducting some interviews in just a little bit. We're going to be also talking about survey methods, and we talked about the techniques of conducting surveys and how awesome that we must follow the rules, the technical rules of the guidelines of validity and reliability, and the guidelines of how to use constructive validity versus face validity. And remember, we told you the difference between face validity and constructive validity versus content validity. I think you recall that again also, John and Williams, when we talked about that in class. We also talked about, in addition to validity, face validity, construct validity, we talked about criterion validity. And we said that when we look at criterion validity, what are we looking at? We're looking at existing instruments and how they measure up to some of our instruments that we have developed. Two different instruments measuring up, assessing the same idea and the same philosophy of the same concept. And then here again, face validity, just a quick review. Face validity doesn't look superficial like it was designed to assess what it was the measurement that we were asking to assess. We talked about content validity. Does it have the elements, the components involved in it for that concept or that construct? Then we also talked about construct validity. And what does construct validity mean? Absolutely, scholar. Construct validity here again means that does the instrument measure up to the concept that it was designed to measure? And then the last type of validity we talked about again was criterion validity. Very good, very good. So we have the different measurements or the different techniques of assessing of descriptive research. Correlation, interviews, questionnaires, archival studies, remember archival studies, meta-analysis, content analysis, epidemiology, which is basically what? Absolutely, it's assessing what the CDC would be doing, assessing different diseases with respect to the different population. And then we talked about the other measurements of descriptive research, and what was that again? That was physiological measures. Absolutely, you're correct on that. And what would be an example of a physiological measure in today's time? A physiological study in today's time? We would compare what? Absolutely, students, absolutely. COVID, perhaps. We're looking at COVID and how COVID has affected the different population. Absolutely. We could also be looking at reaction time studies. We could also be looking at blood pressure, secretion of sweat, which I think I'm sweating down this hot room. Good, very good. But the other one that I did not cover with you yet is the one that I'm going to discuss with you today, and that is correlational designs, correlation research methods. And under the umbrella of correlation research methods, it has its own sub-methods too. But let us stop and define exactly what correlation research methods are. But before we do that, let me give you of course it's on the PowerPoint. Let me give you the guidelines, the goals and objectives, what we're trying to do today. And so let's look at the goals of this lecture for today. The goals is to understand the concept of correlation and to define the concept of how we can use correlation on a daily basis when we were conducting some research. We use it all the time. We make comparisons between variables. It is also to show us how to create and interpret the scatter plot also to show us how to use what is the regression line, when and how to compute Pearson. There are other computations that we can use, a statistical analysis besides the Pearson, but the Pearson is a classic. It gives us the interpretation of the data, allows us to draw a line between variable X and variable Y. And then we want to show you what is meant by the significance of a correlation. And also, in addition to the Pearson, as I told you before, there are other statistical analysis, and when and where do we to use the statistical analysis? We use the Pearson as a classic. We can use Spearman rank, as I gave you the homework assignment. Spearman rank when the numbers are just simply too large to plug in. Let's say a number of 30. X is 30, Y is 40. These numbers are too large to plug into the formula that we utilized just the other day with the Pearson. And so we would use the Spearman rank analysis. And then there's another type of statistical analysis with correlation that we can conduct, and that is the Kendall's coefficient W. And we use Kendall's absolutely, John, you're on the target. We use Kendall's when we have judges. We have maybe, 5 different judges, Judge A, B, C, D, and maybe E. And these judges are evaluating different projects 1, 2, 3, 4, and 5. And we use the Kendall's coefficient W in that case because we're looking at judges and we're looking at one or more, we're looking at different projects with respect to the judges. And then, of course, we know for a fact, and you've done it already, you've computed it already, we can use the z-score correlation when we're doing correlation analysis. So let's look at this. Another guideline, another outline of the lecture, we're going to look at the logic of predicting scores when you're using linear regression and we're using R squared. And I told you again how we compute R square. We'll review that again in just a moment when we compute the Pearson. So let's look at this is the outline, this is the objectives, and here again you can review on videos how to compute it, how to understand and interpret correlation, and how to go and consult the significance table. These are YouTube videos that I encourage you to read, encourage you to view, brother, as a means of gathering additional input, as a means of interpreting the data. Now, let's stop and define exactly what is correlation. Correlation research method is looking at variable X and variable Y. We're trying to see if these two variables are they significant enough to make predictions if they are related to each other. If variable X is related to variable Y. An example being, let's say, running. I tend to run every day. I tend to exercise every day. Does running, could be X. Does running is X. Let's say on some sort of scale, the pace in which I run on a scale. Does it relate to Y? Y could be the reduction of weight. Are they related to each other? Weight loss. And so when we're looking at correlation, we're looking at two variables, variable X and Y. And it does not, if they are related, it does not say that X causes Y, that it's a causal, one causes the other. We only know that a causal relationship deals with what? What kind of research design? Absolutely, an experimental design. That one variable causes the other. But here again, with correlation method, it just tells us if these two variables, they do what? If they are related to each other and to what degree that the relationship exists. And it allows us to make predictions. It also simplifies that the scores in one variable can be interpreted with the scores of another variable. And here again, the data that we receive, the data that we compute from doing a correlation analysis. Let's say, let me just give you some examples of data, and we know that we're dealing with what? Pairs of data. Let's say participant number 1 has a score on let's say exam, let's say this is exam 1, and let's say this is their final grade for the course, for instance, or let's say the final grade for the course. final grade. And so let's say that this person made a score of 90, the final grade was a 92 for the course. If this exam is related to, the exam one's related to the final grade score that they make for the test. Or let's say, here again, participant number 2, participant number 3, and on and on and on. So let's say that we're looking at a set of data, pairs of data. And so when we put it in the Pearson formula, and we showed you the Pearson formula in just a moment. We put it in the formula, it gives us a coefficient. It gives us a statistical analysis. And that statistical analysis coefficient is, for instance, for Pearson, it's R. For Skillman rank, it is R sub S. For Kendall's, it is W. And for Z-score correlation, it is ZS. So we get some sort of coefficient for the data analysis. Now, that coefficient can be turned into what? That data, we can plot the data in terms of what? The scores. And we can plot it in terms of a scatter plot. And or in other words, we can tell if correlation gives us 3 things. It gives us the direction of the relationship. And look at this for an example. Here again, a scatter plot. It gives us the direction of the relationship. And this tend to be a what? As variable X is increasing, cups of coffee consumed, and the nervousness measurement. It gives us a what? A positive relationship. The more coffee I consume, the more nervous a participant is. A positive relationship. And with respect to a positive relationship, there are degrees of positive. There is considered, as we told you, I think we told you, remember again the other day, we told you the coefficient ranges anywhere between, that coefficient score would range anywhere between a +1 or a -1. However, if it is and this tends to be high positive, the correlation would be what? In the 0.90, 0.80, 0.70s, if it's a high. If it is a moderate correlation, meaning it is an average correlation, well, the scores would be in the what? This will be high correlation. This is a moderate correlation. And the scores would be what? In the 60s, 0.60s, and in the 0.50s. If it is a low correlation, low meaning the 2 variables with coffee consumption and nervousness it's positive, but it is a weak positive, a low positive. It would be in the 0.40s and in the 0.30s and in the 0.20s, and even it could be in the 0.10s. Absolutely, you're correct about that. That means, what does a positive mean? It means that both variables are going in the same direction. Variable X increases, so does variable Y increases. Now, however, I think that I have here an example of a negative relationship. This is a positive one. Here again, another study looking at a positive relationship. Looking at what? Hours spent studying per day and test scores. It's a positive relationship. You know for a fact, the more hours you spend studying for this class than any other class, you'll reap the results of it. But there could be a negative relationship. Now, what do I mean by a negative relationship? Again, I told you that correlation gives us the direction of the relationship, and it also gives us the value of the coefficient. So what do we mean by a negative relationship? A negative relationship means that as variable X is increasing, hours watching TV per day, and hours of sleep, as variable X is increasing, what is decreasing? Variable Y is decreasing, meaning you're not going to get that many hours of sleep if you're watching TV all day. So it is a negative relationship. And here again, there could be a high negative, a moderate negative, and a low negative. With respect to the value of R. Okay? And so here again, we want to share with you that there could be not only a positive and a negative relationship, there could be a nonlinear relationship. And what does a nonlinear relationship mean? We cannot draw a straight line through that relationship. It is a linear relationship. a nonlinear relationship. And then there could be, here again, you're absolutely correct. It could be a what? It could be a zero, no relationship at all. And what does it mean by that? Looking at the graph, it means that we cannot possibly, we cannot draw, absolutely correct, scholar. We cannot draw a line at all. And so there is no correlation. We cannot draw a line between variable x and variable y, indicating no correlation at all. Now, I want to stop at this point because I want to give you a chance to review with each other your idea. We're going to take a moment or two to review with each other your idea of your correlational study. What would you be looking at? Give me variable x and variable y. And give me also, discuss with each other, discuss with the groups of two, of course, discuss with your peer, what would be your hypothesis? What is the variable x, what is variable y, and of course, what would be your hypothesis? Let's take a moment to group into groups and look at that with respect to this before we go into, here again, looking at the value of computing Pearson. I want to give you an idea, get a feel for it before we go into compute Pearson.